Hello everyone, this is Sarthak and welcome to the channel. So as I promised you guys, so this is the part 2 of your remaining questions from your PG entrance. Okay, so let's just begin with our topics. Okay, see, the first question is which one of the following compounds gives a primary alkyl upon reaction with methyl magnesium bromide? Okay, see, the option number A, that is ethylene oxide. See, here this is a methyl magnesium bromide. Here your negative charge will attack on this electrophilic carbon and this one will shift to oxygen. Okay, so this will be formed. Okay, in the next step hydrolysis takes place and the product, that is primary alcohol, is formed. Okay, so the correct answer for this particular question is A. Okay, switch over to our next question, that is which one of the following statements is correct for alkyl halide? So the options are A, alkyl halide will always show SN1 mechanism. Okay, this statement is wrong because 1 degree, 2 degree and 3 degree alkyl halide, basically 2 and 3 degree alkyl halide, they show SN1 mechanism. But in case of 1 degree alkyl halide, they rather prefer SN2 mechanism over SN1 mechanism. So the first statement is incorrect. So coming back to next statement, that is in a unimolecular reaction, increasing the temperature does not favor E1 mechanism. Okay, actually, if you increase the temperature, then elimination reaction favors. So elimination reaction depends upon temperature. Fine. So this statement is incorrect. The next statement, that is E1 mechanism is favored over SN1 mechanism for primary alkyl halides. Okay, this is also incorrect because see, this is your primary alkyl halide. Okay, so in primary alkyl halide, there is less steric hindrance, or you can say there is lesser bulky group is present. So S1 mechanism will favor over E1 mechanism. So this statement is also wrong. So we have left with one option, that is option number D, which is correct answer for this particular question, that is E1 mechanism is favored over S1 mechanism for tertiary alkyl halides. Okay. So the question number 3, that is aryl halides are less reactive towards nucleophilic substitution reactions as compared to alkyl halide. This is due to, okay, see, this is your aryl halide and suppose this is your alkyl halide. Okay, so the carbon here is sp2 hybridized and the carbon here is sp3 hybridized. Okay, so remember one thing, nucleophilic attack to sp2 hybridized carbon is much more difficult than that of sp3. So in aryl halide, the nucleophilic substitution are less reactive as compared to alkyl halide due to presence of sp2 hybridized carbon. So the correct option for this particular question is D. Okay. So the next question is identify the reactant X in the following reaction sequence. Okay, so they have asked you to determine the unknown compound, that is X. So this is your answer, that is aniline is the correct answer, that is option C. So have a look on the conversion. See, this is your aniline. If aniline reacts with bromine water, then electrophilic addition reaction takes place and it will give you this product. Okay, so bromine will be attached in ortho and para position. Okay, if this Y is treated with NaNO2 and HCl, then the product Z is formed. Okay, so this product Z, that is diazinon salt, will be formed, and if diazinon salt is heated in presence of ethanol, then your required product is formed. Correct answer for this particular question is aniline, that is answer C. So the next question is, which one of the following structures represent the major products in the following reaction? Okay, so this is your reaction, and this compound reacts with H pair. Here a lone pair on oxygen attacks H, and this is formed, and this compound is formed. Okay, so here water is stable, and this is eliminated to give rise to carbocation, and this carbocation is formed. Okay, so you have a nucleophile that is Br minus. So this nucleophile can attack both sides, above the plane as well as below the plane, to give you racemic product. Okay, so this racemic product is obtained. Okay, so the correct answer for this particular question is A. Okay. Okay, the next question is, if 2-methyl butane will be subjected to monobromination, then how many isomers will it form? Okay, so this is your 2-methyl butane, and this is subjected to monobromination in presence of light. Fine. See, these two methyl group are in same environment. Okay, and this particular compound, that is 2-methyl butane, will give you 5 isomers. I have listed it in the notes on like 5 isomers. See one by one. So bromination can be possible at 1 degree, 2 degree, 3 degree free radical. So this is the case. These are 5 isomers which is given by 2-methyl butane. See, in this case bromine is substituted here, and in this case the bromine is substituted by 2 degree free radical, and here this is 1 degree free radical, and this is substituted by 2 degree free radical, but this is your chiral carbon. Okay, so this will give you two product. Fine. So 1 2, this will give you 2, that is 2 plus 2 4, and we are left with last one, that is this is 1 degree free radical, and these are all the 5 isomers which is given by 2-methyl butane. So the correct answer for this particular question is C, that is 5. So the next question is, calculate the lambda max value for the following compound using Woodward and Fisher rules. Okay, so here is the compound. Here this is your alpha, this is your beta, and this is your gamma, and this is your delta. Okay, so for this particular compound, your base value, that is 215. Okay, so here there is present of extended double bond conjugation. So the value of extended double bond conjugation, that is 30. Okay, so here this is your beta residue. The value of beta residue is 18, and the value of your delta residue is 12, and here this is exocyclic. So for exocyclic the value will be 5. So in total, if you're adding all these values, so you'll get 279. This will be your answer, that is option number B, that is 279 nanometer is the correct answer for this particular question. Okay, question is, which one of the following compounds with molecular formula C4H9NO2 shows NMR peaks at 5.30, 4.10, 2.80 and 1.20. Okay, this question from your NMR spectroscopy, right? See, if you are preparing for any entrance examination like in chemistry, you will definitely find 2 to 3 NMR questions on your paper. Okay, so if you are interested in solving this type of question in 30 to 40 seconds or within 1 minute, then tell me in the comment section in a short video on this topic, so that you are able to solve this type of problem. Fine. So see, the answer for this particular question is C. Why the option C is correct? look at the structure first. Okay, here 3 hydrogen is present on this carbon, and the adjacent nitrogen has only 1 proton, and according to n plus 1 rule, this will give you doublet, and the doublet shows at 2.80. Fine. And here hydrogen, the single proton is present, and nitrogen, an electronegative element. Fine. So this will, the peak will show at 5.30 ppm. Fine. Carbon has 2 hydrogen, and this will show quadrate. Okay, because here 3 hydrogen is present. According to n plus 1 rule, this will give you quadrate, and this will give you triplet. And because here 3 hydrogen is present and here 2 hydrogen is present, fine, so this will give you 4.10. The peak will show at 4.10 because here carbon is attached to oxygen. Fine, oxygen is more electronegative, so your ppm value will be higher in case of this carbon particular, and this carbon, the NMR value will be 1.20 ppm. So the correct answer for this particular question is C. Okay, see the question number 9. The sodium extract of an organic compound develops a blood red color on treatment with FeCl solution. Okay, the ion responsible for the color test is, okay, so see this particular ion is responsible for this color test. Okay, see here this complex is formed which is blood red in color. That's why this particular ion is responsible color test. Okay, so the answer for this particular question is B, 9B. Okay, the next question is, which one of the following statements is correct regarding the following reaction? Okay, so the compound, here is the compound is treated with tertiary butoxide. See, your tertiary butoxide, this is your bulky base. Okay, so here bulky base is given, so it will follow Hoffman product. Here one hydrogen is present, so your tertiary butoxide and this base will abstract one hydrogen from less steric side to form exocyclic alkene. Okay, this will form exocyclic alkene. The product will be double bond CH2. Okay, suppose instead of tertiary butoxide, if they have given you KOH, then your endocyclic alkane will be formed. So you have to remember the basic difference between KOH and tertiary butoxide base. Okay, so the correct answer for this particular question is D. Okay, so the question number 11, that is, suggest the product of the following reaction. Okay, so here there is the compound which reacts with NaOCH3. Remember, this reagent acts as a nucleophile, not a base. Okay, so here oxygen, the lone pair of oxygen attacks on the electrophilic center, that is on carbon, and this bond shifts towards oxygen because oxygen is more electronegative. See, this will be formed. Okay, so this product undergoes protonation to form the required product, that is your option B. See, the option B is your correct answer for this particular question, because see, if you are thinking there will be dehydration, this will not happen, because for dehydration your hydrogen and OH group must be anti-periplanar to each other, but in this case they are periplanar to each other, means they are in same plane, so no dehydration will be taking place. So the required product is this. So the option B is the correct answer. So which one of the following reactions is not an example of U1CB reaction? That is elimination by conjugate base mechanism. Okay, see, in U1CB reaction, first step, proton losses to form conjugate base. That is, suppose here one hydrogen is present here. The first hydrogen is abstracted by base, and this will form okay. So the conjugate base, that is carbanion, is formed here. Okay. So, and the carbanion should be stable. And remember, the negative charge near carbonyl group is more stable. So, in first three cases, the negative charge is present near to carbonyl group. So, we have left with last option. The carbanion is found in this particular compound is less stable. So, the option D is the right answer for this particular question. Okay. 13. What is the correct statement for the given reactions? Okay. See, they have given you two reaction. Fine. In reaction A, see, I can transfer this particular compound into this form. Fine. So here, the acetate ion will abstract this hydrogen. Okay. And this bond will shift towards this direction, and your leaving group will be out. Okay. Your syn product is formed, and this process is slower usually. Fine. So in your second reaction, see, I am transferring it into this form, and when the acetate ion abstract this proton, this bond will shift to this direction, and the leaving group will be out here. So the product formed in this process is due to anti-elimination, and this will be a faster process. This will be faster. Okay, since your abstracting group and the leaving group both are anti-periplanar to each other. Fine. So the correct answer for this particular question is A, because B reacts faster than that of A, because here anti-elimination takes place. So the question number 14, which is the correct order of the nucleophilicity in the following options? Okay. So remember one thing, if you have anionic nucleophile and neutral nucleophile, obviously your anionic nucleophile will be more stable than that of your neutral nucleophile. Okay. So see, in the option number C, there is presence of anionic nucleophile. So this will be more stable than that of neutral nucleophile. So for this question, the correct option will be C. Okay. So switch over to our next question. That is, which one of the following statements is true about the reaction given below? So this is your reaction, and the correct answer for this particular question is A, as it is processed by concentrated SN2 pathway. Okay, actually what happens, OCH3 minus will attack to this side. Okay, so this reaction proceeds by concentrated SN2 pathway. Okay, so the correct option is A. So the next question is, which one of the following substituents on the benzene ring is not a meta-detecting group in electrophilic substitution reaction? Okay, so I am taking particular this option. Okay, see, bromine is a electron withdrawing group. Alright, and this will show minus I effect. Fine, but this is an ortho-para directing group. Remember this. This is an ortho-para directing group because of your flush R effect. Okay. So the correct answer for this particular question is C. So the next question is, which one of the following alkanes exhibits optical activity? Okay, you must be knowing actually, for optical activity there must be a chiral center. Fine. So what do you mean by chiral center? If all the four groups attached to the carbon are different, then this carbon is called chiral carbon. Fine. If there is a chiral carbon, then the compound will show optical activity. So see, in the option number D, that is 3-methylhexane, there is a chiral center present in this compound. Okay. So the option number D is the correct answer. So switch over to our next question, that is, what will be the most appropriate reagent for the following transformation? Okay, this is your Wittig reaction. Fine. So the reagent for this particular question will be B, that is PS3P CH2. Okay, so go through the Wittig reaction mechanism, you will get that answer. Fine. So correct option is B. So our next question, question number 19. Which one of the following carbocation is more stable? Okay. So you know the stability of carbocation. This will be first your benzyl, then your allylic carbocation, then your 3 degree, then 2 degree, then 1 degree. Okay. So here in the option number D, this is your 3 degree carbocation as well as allylic carbocation. Okay, because see there are 3 alkyl group attached to this carbon. Okay, so this will be more stable. For question number 19, the correct answer is D. Okay, so switch over to our next question. Question number 22 says, name the process associated with acylation of benzene. Okay, so you know acylation, I've heard it before, like Friedel-Crafts alkylation, Friedel-Crafts acylation. So acylation reaction usually involved with Friedel-Crafts reaction. What happened there? Actually, here in Friedel-Crafts acylation, suppose this is your benzene ring. So acyl group is introduced to the benzene ring, CH3COCl in presence of anhydrous FeCl3. So you will get COCH3. So introduction of acyl group to the benzene ring is called Friedel-Crafts acylation reaction. Okay. So the correct answer for question number 20 is A. One of the following statement is incorrect. Okay. First step of photochemistry is the excitation state of electron. This is correct statement. Next, when a molecule or atom in the ground state S0 absorbs light, it is one electron is excited to a higher orbital level. So this is also correct. So option number C. Next, photochemical reactions are caused by absorption of UV light only. Actually, this is wrong statement because reaction usually occurs in the range between UV and visible region, that is 290 nanometer to usually 290 nanometer to 780 nanometer. Okay, so the correct answer for the question number 21 is C. Okay, the next question number 22. Here, arrange the following intermediates in the descending order of their stabilities. Okay, this is a good question actually. Here, see, electron donating group, that is OH, NH2, CH3, Cl, all of these are stabilized the carbocation attached to the intermediate compound. Okay, so the electron donating nature, that is electron donating ability, will be NH2 greater than OH greater than CH3 greater than Cl. Okay, so the correct answer for the stability of these 4 compound will be D. The answer D is the correct option. Due to the electron donating ability, this will be more stabilized. So the correct answer for 22 is D. Question number 23. The IUPAC name of the following compound is, okay, see, this will be your 1, this is here 1 carbon is present, this will be 2, this will be 3, then 4, 5, 6, 7. So here what will happen? 3 bromo, this will be 1, 2, 3, 3 bromo, 4 chloro, hept 6 in YNE. So this will be your correct answer, 23C. Okay. So next, which type of macromolecules carries out catalysis in biological systems? Okay, so actually in biological system, proteins are one of the important parts. So here protein carries out the catalysis process in biological system. So for the question number 24, the correct answer is A, that is proteins. Okay, next question is, a nucleotide is considered from which of the following units? Okay, so you know nucleotide is formed by the combination of nitrogen base, sugar and phosphate. So the correct answer for this particular question is B. This is the direct question from your textbook, so you know it. Okay. So next is 26 number question. The change in free energy of a reaction at equilibrium is. So let's consider a equilibrium reaction. Suppose I am taking A equilibrium with B. Okay. So your del G will be G product minus G reactant. Okay. So your change in free energy, that will be an free energy of product minus free energy of reactant. Since both are in equilibrium, so the free energy of product will be equal to free energy of reactant. So this value comes out to be 0. So for the question number 26, the correct answer is 0. Okay. So the next question is, if doubling the initial concentration of a reactant doubles the half-life period, that is T half of the reaction, then the order of reaction is. Okay. So if you remember, the half-life of zero order reaction, that is T half will be equal to A naught, that is initial concentration, upon 2K. That implies T half is directly proportional to A. So your half-life for zero order reaction is directly proportional to its initial concentration. So if you are increasing your initial concentration, then your half-life will also increase the same times as you increased your initial concentration. So if you are doubling the initial concentration of the reactant, then its half-life will be doubled. So question number 27, the correct answer will be D. That is, this will be a zero order reaction. Okay. So the next question is, if psi is a wave function, then what is the probability of finding an electron in a given region within the atom? Okay. So psi is your wave function. If we are taking square of the amplitude, that is psi square, which is called probability density. This is called probability density. Okay. So the probability density or psi square will be a measure of the probability of finding an electron in a given volume. So for question number 28, the correct answer will be C. Okay. So next question is, 1 coulomb is the charge of. Okay. 1 mole of electron carries charge of 96500 coulomb, which is equal to 1 Faraday. Okay. So if you are calculating for 1 coulomb, this will be 1 upon 96500 mole. Okay. So for question number 29, the correct answer will be B. Okay. So the next question is, so this is your last question, because I have already discussed the other questions in part 1. So you can go through those videos. Okay. So the pressure correction in the boundary equation is due to. So the answer for this particular question is B. Attractive force of the molecules towards the boundary wall. Okay. So with this answer, we have already finished all the questions which I have asked in CPET 2020. Okay. So if you have any queries, you can ask me over the comment section. Okay. So thank you.